All right, take a look at number 1. Can we use elimination on number 1? No, it would be nice if we could. Elimination is a lot easier than substitution, but we can't. So we need to solve the bottom for either x or y and plug it in using substitution. So I'm going to subtract y, x equals 2 minus y, and I'm going to plug that, nope, not there. I'm going to plug that in right here. So 2 minus y squared plus y squared equals 2. Everybody get that? So I need to distribute this out. 2 minus y times 2 minus y gives me 4 minus 2y minus 2y plus y squared. Now I need to add to that y squared and what else? It equals 2, but I need it to equal 0, so I'm going to subtract the 2 over. So I'm going to subtract this 2 to that side, and I have minus 2. Okay, so I can put my y squareds together, 2y squared, and then I can put my y's together, minus 4y, and I have a 4 and a negative 2, which is positive 2 equals 0. Everybody understand that? Okay, what should I do now? I could do the box, but I want to do one thing first. I want to divide by 2. Yes. It turns into a 1. Yes. So I'm going to get y squared minus 2y plus 1. And now I stick that in the box, or hopefully you can do this in your head, right? Are there two numbers that multiply to be positive 1 and add to be negative 2? What are they? Negative 1 and negative 1. So if you put this quadratic in the box, you have to use the box, because you have to multiply the 2y squared and the 2. But if you divide by 2, then you can probably do that in your head, and you get y minus 1 and y minus 1. So y equals 1. So how many answers does this have? At least 1. So I'm going to go back. That's not what I wanted to do. Let me get this out of the way. So maybe I'm going to take that 1 and plug it in for y in that equation, and we get 1. So it does just have one solution, 1 comma 1. If you plugged it in and you ended up with plus or minus 2, then it would be 2 comma 1 and negative 2 comma 1. So basically, if you plug it back in and you end up with an x squared or a y squared, you'll have more than 1. And sometimes when you plug it back in, it won't work. It is possible to get like 3 and negative 2. And if I were to plug those in, say, here, if I were to stick that in there, negative 3 equals x squared minus 1. If I add 1, I would get negative 2 equals x squared. When does x squared equal negative 2? Hold on, I know. Don't worry, I'm making this up. So when does x squared equal negative 2? It doesn't. So this would actually disappear. So just because the x works, that doesn't mean that the y is going to work. And I know I plugged it into a y, but I was just showing you something. Oh, negative, whatever. I messed that up. I messed it up all over the place. But just because you get an answer to one of the equations doesn't guarantee that those answers will work in the other equation. So sometimes you'll end up with 2 answers and only one will work, and sometimes you'll end up with one answer and it ends up having 2 answers attached to it. And you just find that out when you plug it back in. Okay, look at number 4. What should we do for number 4? Elimination. So I'm just going to add straight up and down. 2x squared, y's cancel, equals 0. What is the only root for that? 0. The only number you can square and then times by 2 and get 0 is 0. So how many answers does this have? Probably 1, maybe 2. We have to plug it back in to figure it out. So I'm going to put 0 in the top. And I get 0 plus y squared equals 16. Now what? Square root it. Not 8. Not 4. Plus or minus 4. So what does that tell me about my solution set? There are 2 of them. 0, 4, and 0, negative 4. Does that make sense? Okay, look back at number 3. It is possible to make number 3 really nasty, or it's possible to make it pretty easy. What would you do for number 3? So, if we subtracted x squared over here, now we could use elimination. That would work, okay? Or we could do substitution. So I'm going to plug this in there, and you'd get x squared plus x squared minus 1 squared equals 13. You're going to end up with an x to the 4th equation, which is really nasty. You don't want to do that. It will work, but you don't want to. Here's what I would do, and this is kind of a trick. Is it possible to isolate the x squared? Yeah, how would I isolate the x squared in the bottom? Add the 1 over. So x squared will equal y plus 1, right? Now I just substitute x squared. We can substitute anything we want as long as it gets rid of one of the variables. So I'm going to put y plus 1 right there where x squared used to be. Do I need to raise it to the 2nd? No, because it does equal x squared. So I get y plus 1 equals y squared. Y plus 1 plus y squared equals 13. So I'm going to reorder. Y squared plus y, I need to subtract 13. 1 minus 13 is negative 12. So how does that factor? Not 6s. 2 numbers that multiply to be negative 12 and add to be 1. 3, negative 3, and positive 4. So negative 3, positive 4. So I have 3 as a root. And I have negative 4 as one of the roots. Now where should I put those to get my answers? Well, we're solving for x, so I'll put them in here. It doesn't really matter, but that one will be pretty easy. If I put in negative 4 for y, negative 4 plus 1 gives me negative 3. When does x squared equal negative 3? Not in the real world, right? It would be the square root of 3. So this answer actually doesn't work, because you can't have x squared equaling a negative number. If I put in 3, 3 plus 1 is 4. When does x squared equal 4? Square root, x equals Plus or minus 2. So there are actually two answers here. 2 comma 3 and negative 2 comma 3. I put in y equals 3, and when I plugged in y equals 3, I got x equals plus or minus 2. So that y is attached to two different x's. Does that make sense, Hayden? No? You got it? Okay, turn the page. So you could do that trick on number 9. You could add 4, and you get x squared equals y plus 4. And then you can replace x squared with y plus 4. That makes it a lot easier. Okay, but number 11 is the one I want to do. How would you do number 11? Divide the bottom by x or y. It doesn't matter. So let's divide the bottom by x. And I get y equals 2 over x. Well, chances are this doesn't actually have fractions in the answer. So let's plug that in. I'm going to stick it right there. X squared plus 2 over x squared equals 5. Okay. Now what? What is 2 over x times 2 over x? 4 over x squared. So x squared plus 4 over x squared equals 5. Now what? Yes, that's the trick here, is we have to get the x squareds together. Close. No, we don't want to times by 4. Well, what's the problem you see here? The 4 is not the issue. It's the x squared in the denominator. We could times everything by x squared. Or we could, well, I mean, we're going to do that eventually. I could subtract the x squared over minus x squared. Not divide. Times by x squared. So if I put an x squared here, those cancel. And if I times these by x squared, we get 4 equals 5x squared minus x to the 4th. I know, no, it was a positive 5 already. Because it was, well, we multiplied by a positive x squared. So let me write that out one more time. So we have 4 over x squared equals 5 minus x squared. So I times by x squared, that cancels, and I times this by x squared. Whatever you multiply on one side, you multiply exactly the same thing on the other side. So I get 4 equals 5x squared minus x to the 4th. Now, I need everything on one side. Do I want to move everything to the right or to the left? Let's move it to the left because the x squared is positive, or the x to the 4th will be positive over there. So, x to the 4th minus 5x squared plus 4 equals 0. Yeah, it looks hard, but what if it said x squared and x? Could you factor that? What would it be? So it would look like this. X plus, or x minus 4 and x minus 1, right? If it was x squared and x to the first, then it would factor to be x minus 4 and x minus 1. So if it's x to the fourth and x squared, yeah, it's just x squared minus 4 and x squared minus 1. So it looks harder, but actually it's the same. Okay, so these are differences of squares, right? X squared minus 4 can create two conjugates, x minus 2 and x plus 2, x minus 2 and x plus 2, and the other one, x minus 1 and x plus 1. So how many answers does this have? 4. And they are 2, negative 2, 1, and negative 1. So if you get an x to the fourth quadratic, treat it like an x squared quadratic and factor it like you normally would, but instead of x and x, it's x squared and x squared. And then all we have to do is plug those back in, and that's going to be easy because we have the equation y equals 2 over x. So you're going to plug in 2 and negative 2 and 1 and negative 1. So when you plug in 2, 2 divided by 2 is 1. When you plug in negative 2, 2 divided by negative 2 is negative 1. When you plug in 1, you get 2. And when you plug in negative 1, you get negative 2. Now, the same thing is going to happen on number 12. You're going to divide by x, substitute it in, multiply by x squared, and you're going to end up with an x to the fourth quadratic. Factor it as though it was a regular quadratic, and you're going to end up with 4 answers. And then plug those 4 answers back in to get the roots. Okay? That's everything I know. Good luck.